Solutions and solubility. Solutions contain small particles. In a solution, dissolved particles or solutes are surrounded by solvent particles. The solvent is the medium in which the solute particles are dissolved. Solutions are homogeneous mixtures. Solutions are homogeneous mixtures because, regardless of the sample size, the ratio of solute particles to solvent particles remain the same. So in this solution, whether I take this whole thing or this little snapshot, it's a uniform mixture of the solute particles shown in purple and solvent particles shown in green. If you took a 5 milliliter sample or a 200 milliliter sample of a solution, you would find the exact same ratio of solute to solvent. Salt water is a classic example of a solution. The sodium ions and chloride ions are dissolved in the solvent, creating a uniform mixture. Most water that we encounter in our day-to-day lives is a mixture. Water from the tap or freshwater sources are not completely pure. Minerals from rocks and soil dissolve in the water, however, in such small portions that it is not considered salt water. The solubility of a solute is defined as the amount of solute that can dissolve in a certain quantity of solvent. So the amount of solute in a certain quantity of solvent is the solubility. It depends on the temperature, the solute's state, is it a solid, liquid, or gas, and the solute's affinity for the solvent. Unsaturated solutions contain less than the maximum amount. In other words, more solute could be dissolved into the solution. So you see that over here on the left. There are a few solute particles, but we could dissolve more. In the case of an unsaturated solution, you wouldn't see any solute particles anywhere in the solution because they would all be dissolved. A saturated solution contains the maximum amount of solute that can be dissolved and stably maintained at that temperature. Often, but not always, precipitate is also present. So in a saturated solution, we dissolve the maximum amount, as you see floating around in the solution up here. But down below, you might see some undissolved solute particles because the solution itself is holding the maximum amount. And then a supersaturated solution contains more solute than saturated solutions. They are unstable in that they quickly transform into a saturated solution if disturbed, including by the addition of a seed crystal. So in a supersaturated solution, if you compare these two, you can see that in the supersaturated one on the right, more solute particles are dissolved than the solution can stably hold at that temperature. So any small tiny disturbance and all this excess solute will come out of the solution and you will see it as a precipitate at the bottom. Okay, so let's summarize that. In an unsaturated solution, which you can see on the left, any additional solute will dissolve, so there's no undissolved solute present as a precipitate. In a saturated solution, undissolved solute and dissolved solute are in equilibrium, so there will often be precipitant present. A supersaturated solution is always clear, and no precipitant is present, since that would disturb the equilibrium, and excess solute would precipitate, yielding a saturated solution with precipitate. Supersaturated solutions can be created by first starting with a solution that is saturated at an initial temperature. So you've heated up the solution enough to dissolve the maximum amount of solute it will hold at that temperature. Then, if you slowly cool the solution so that the amount of solute is above the maximum for that new lower temperature. This is unstable since if any solid solute is added, the remaining excess solute quickly precipitates out, leaving a saturated solution and precipitant. This photo sequence starts with a supersaturated solution of sodium acetate in water. It is clear and without precipitant. Then a crystal of the sodium acetate solute is added in the second image. Since supersaturated solutions are unstable, the addition of that seed crystal causes all the excess solute to crystallize out of solution. The excess solute quickly comes out of the solution, leaving behind a saturated solution and the precipitate, which you see.